Ma'am, could you please start the recording?
I have started.
Okay, ma'am. Thank you.
Okay, so we'll start with this waves numerical revision. The equation of a plane progressive wave is y is equal to 10 sine 2 pi of t minus 0.005x. Calculate the amplitude, frequency, wavelength, and the velocity of the wave. Right? So the general equation for was the general equation for the display when a plane progressive wave, please understand how what is the significance of this expression. When a wave travels through a medium, it makes the particle of the medium to vibrate. Suppose O is the point where the source which creates the wave is situated, right? Let us take P, the particle of the medium. Now this particle of the medium is at a distance of x meters from the source, and it undergoes a displacement of y in a time of t seconds. That was when a wave which is produced by a source. Wave is a disturbance which is produced by a vibrating source. When the wave passes the medium, now suppose let me consider a particle P which is at a distance x from the source. Now this particle will undergo a displacement, right? Y in a time of t seconds. Now let A be the maximum displacement, right? A is the maximum displacement any particle can undergo. So the displacement y of a particle t at a time in a time t seconds, and this particle is located at a distance x from the source, is given by this equation. Y is equal to a sine of omega t minus kx. Boys, these formulas are very important. A represents the amplitude of the wave. Omega is the angular frequency. K, we call it as propagation constant. The value of K is 2 pi by lambda. And the negative sign, this is minus Kx. This negative sign indicates the wave is traveling in along positive x-axis. Are you clear? Boys, are you clear? You have to by heart the equation. Only then you can solve the numerical. Is that clear, boys? What is y? Y is the displacement of any particle of the medium, right? Which is at a distance of x meters from the source. A is the maximum displacement. And what is K? K is equal to propagation constant 2 pi by lambda. Okay.
Ma'am.
Yes.
Ma'am, like in the portions and also in the textbook, there's a section called the relationship displacement relation for progressive wave. So is that this equation, the
Yes.
progressive wave
Yeah.
equation? Okay.
Yeah.
Also,
So
ma'am, in the textbook, and I checked another book as well. It's like
okay.
given sine kx minus omega t.
It can also happen. Next numerical will go for kx minus omega t.
So both are fine
Both
if you
fine.
use.
If
Okay, ma'am.
kx, if yeah, correct. If kx is positive, then it denotes the wave is traveling in negative x-axis, along negative x-axis. If kx, sorry, here kx is negative, so which tells you that the wave is traveling along positive x-axis. Only that much you should know, boys.
All right, ma'am.
Okay. Now this is the equation. Y is equal to 10 sine of, I'll take 2 pi inside, 2 pi t minus 2 pi into 0.005x. Okay, now you compare these both equations. The first one, let me go for the amplitude. What is, sorry, what is the amplitude over here? You compare these two equations. What is your value of the amplitude? Say x is in, y is in meters. Time is in second. Compare this equation with the standard one. So what will be the amplitude?
10.
10 meters. Okay, fine. Next one, they are asking for linear frequency. Let us go for angular frequency. Angular frequency is omega. Now compare the equation, boys. This is omega, sine omega. The argument of t, you know that omega t, omega is the argument of t. Look at this. What is that? Omega is. What is omega? Now, tell me the value of omega.
Ma'am, 2 pi.
Yes, 2 pi radians per second. Boys, you should know the standard equation, then you can compare.
Ma'am, in the case that these values come in centimeters, do we
Yeah,
need?
no, no, you write as per it.
All right, ma'am.
Radians per centimeter, that's it.
Okay, ma'am.
Okay. So angular frequency is over. Now I have to find linear frequency. Boys, have you copied? Because copied down because I have to go for the.
Ma'am.
Otherwise, yes.
Ma'am, in the question, frequency means like both angular
No,
frequency and linear.
generally frequency is linear frequency. If they specify angular frequency, then you have to go. You have to write omega anyway. If it is frequency, linear frequency, you have to find nu, right? For that you need omega. So if they ask for frequency, it is always linear frequency. First write what is angular frequency. From angular frequency, we'll go for linear one.
Oh, okay, ma'am.
Now, once you have copied for angular frequency, then we'll go for linear frequency.
Yes, ma'am, done.
Okay. Shall I erase now? What shall I erase?
Yes, ma'am. Yeah.
Okay, so your angular frequency is 2 pi radians. Now we'll go for the linear frequency. For that, we should know the relation between them. So linear frequency nu. Your linear frequency is nu. So you know that omega is equal to 2 pi nu, or nu is equal to omega by pi. So what was omega in the previous case? Omega was 2 pi, right? Can you identify, boys, omega? So
Yes,
2 pi by 2 pi. So your value is 1 hertz. So nu is 1 hertz. Next, we have to go for wavelength and velocity of the wave. Shall I erase this, boys? Linear frequency, shall I erase?
Yes, ma'am.
Sorry. Next, we'll go for wavelength of the wave. Next one, wavelength. Okay. Now look at these two expressions. 2 pi into, is that the value of, what is the value of k now? What is the value of k now?
Ma'am, it's 2 pi into 0.005.
And you know that k is equal to
Ma'am, 2 pi by lambda.
pi by lambda. Okay, 2 pi by. So then I can write 2 pi by lambda is equal to 2 pi into 0.005. Correct, boss? So now calculate lambda.
Ma'am, I'm getting 1 by 5 into 10 raised to minus 3.
Yes.
Ma'am, I'm getting 1 by 5 into 10 raised to minus 3.
Correct. So
Ma'am, 200.
yeah. So lambda, have you calculated lambda? Now, how will you calculate velocity?
Do you have to differentiate that equation?
No need to differentiate. You get a value of lambda. So you know the wave equation V is equal to nu lambda. So
Yes.
velocity is frequency into lambda.
Ma'am,
Yes. Should I solve for lambda?
what's
Should
the
I
SI unit for lambda?
meters?
Okay.
Distance, right?
Ma'am, lambda was it 200?
Yeah.
Okay, ma'am.
So what is the value of V?
Ma'am, also 200.
Meters per second.
Yes, ma'am.
Ma'am, the velocity. Oh, no, sorry, ma'am, nothing.
Shall we go for one more numerical, boss?
Yes, ma'am.
Go for this. 1 second, boys. I have to call teacher. Just start doing this. Just 2 seconds. I'll come back. So what is the value you are getting here? What is the amplitude? Say y is equal to a sine. Here it is given as kx. It can happen also. It depends upon the phase of the wave. So what is the amplitude now?
A 0.005
meters. Okay, fine. What is the value of k?
Ma'am, when we do the, when we need to calculate something with that equation, we'll take the previous questions one. Omega t minus kx.
Yeah.
Okay,
You have
ma'am.
to always write the basic equation, compare. What is the value of k here? Look at the equation. What is the value of k?
Ma'am, 80.
Okay, 80. Okay, fine. Now what is k? K is equal to 2 pi by lambda.
Yes, ma'am. And lambda is equal to pi by 40.
Okay, pi by 40 meters. Now, that is wavelength. Then if I want to go for time period, third one, what is your angular frequency? What is the value of omega here? Let's compare. What is the value of omega?
3.
3.
3 radians per second. Now, next I have to go for linear frequency. So omega is equal to 2 pi nu, or nu is equal to omega by 2 pi. So it is 3 by 2 pi hertz, correct? Fourth one. Fifth one. What is time period? T is equal to 1 by nu. So that will be 2 pi by 3 seconds. So all these basic equations you should know, boys. Omega is equal to 2 pi nu. K is equal to 2 pi by lambda. T is equal to 1 reciprocal of your linear frequency.
Ma'am, anytime we get pi, do we have to convert it with the 3.14?
Yeah.
Okay, ma'am.
If you don't have time, then you can leave it as such. Or else 3.14 you have to convert.
All right, ma'am.
This is along the negative x-axis.
Yeah, this will because kx is positive, right?
Yes, ma'am. And do we actually need to know that for solving?
No. Sometimes they'll ask. Wait, we'll go for the next numerical where they'll ask you whether the wave is traveling in positive x direction or negative x direction. We'll do one more numerical based on this, and then we'll go for a transverse wave on a spring.
Ma'am, so if the equation is like this, it's negative x?
No, here it is a kx is positive, right?
Okay.
So
Okay,
the
ma'am.
kx is positive means the wave is propagating or the wave is traveling along negative x-axis. If kx is negative, the wave is traveling along positive x-axis. That's the only thing you should do.
All right, ma'am. Okay.
1 second, boys. Is this a traveling wave or a stationary wave? Was here your equation y is equal to 3 sine 36t plus 0.018x. So should I write for omega t plus kx plus phi 0. Phi 0 is the initial phase. Okay. The positive direction of x is from left to right because the wave is traveling from left to right. If it is a traveling wave, what are the speed and direction of its propagation? Anyway, it's given. What will be the speed and the direction of its propagation? What will be the speed? What is the speed, boys, here? Can you check? How will
ma'am?
you go for the speed? Yes,
Ma'am, what's the last term in the
that is
equation?
the initial phase.
Okay,
Whether
ma'am.
it is 90 degrees or whether it is 0 degrees or 170 degrees. Okay. You know how to calculate the amplitude. First, go for the amplitude and the frequency. 50 is the initial phase. Amplitude and frequency, you should know how to calculate. Amplitude is direct. You can easily find amplitude. You go for angular frequency omega. Then you calculate linear frequency nu. Then you find what is k. Then what is the least distance between two successful crests in the wave? What is that? What will you write, boss? What is that? The least distance between two successive crests.
The
Wavelength.
Wavelength is. So they will not give you the value directly. They will just state that what is the. Now start doing calculate. I think so. You can calculate.
Ma'am, so initial phase means like it doesn't start from 0.
Zero. It doesn't start from zero.
Okay, ma'am.
So here
Okay.
it is pi by 4.
Ma'am?
Yes.
Ma'am, over here, the direction of
Positive.
the x-axis is positive, right? But
The
then
positive
kx is
direction.
positive.
No, they are telling you the positive direction of x is from left to right. So in which direction this wave is going to travel? Positive kx means it's going to travel in the opposite direction. The positive direction
Okay,
of x. So which means this wave will travel from right to left.
okay, ma'am.
Because if kx is positive, then the wave will move in negative x direction. If the value of kx is negative, the wave will move in positive x-axis. Keep that in mind and find.
Oh, ma'am, so here it's negative, right? Okay, ma'am.
Now just calculate. Is that the velocity is 20 meter per second?
Ma'am, the reason that this is a traveling wave is because its displacement varies with time.
Yeah.
Should we give any reason?
No need. You can just state, is this a traveling wave? That's it.
Okay, okay, ma'am.
do it, boss, because if you want to check whether it is remind me, transverse wave, I think so. If you can check your textbook numerical 15.11, or transverse displacement of a string clamp. See, in a string, the waves which are produced are stationary waves. What are stationary waves? When two waves travel in opposite direction with the same frequency, amplitude, say with the same velocity in the same medium, but in the opposite direction, then they superimpose on each other and produce stationary waves. That clear, boys? When two waves of traveling with the same speed in the same medium with same velocity, same frequency, but the waves are traveling in the opposite direction, they superimpose on each other and gives rise to stationary waves. Now the question is this a stationary wave or a traveling wave? When you have only one function, any trigonometric function, when a wave is represented by only one function, it is a stationary wave. In some cases, you will have, in some cases, you will have, suppose if I'll give you the example, y is equal to, the question is like the 0.06 sine 2 pi by 3x into cos 120 pi. Some questions are like this, right? In this case, how many functions, trigonometric functions you have? Two trigonometric functions. This represents superposition of two waves. Here, only one trigonometric function is involved. Someone asked me how to check whether it's a traveling wave or a stationary wave. For traveling wave, you will have your displacement either in a sine function or in cosine function. But for stationary waves, boys, stationary waves are like this. A wave is traveling in one direction, right? It hits an obstacle and gets reflected back. So this is a reflection, two waves superimposing on each other. These waves are called stationary waves. For stationary wave, you will have two trigonometric functions, each representing each of these waves. So this is the way to distinguish between a traveling wave and a stationary wave.
Ma'am, so the two functions have to be multiplied with each other?
Yeah, that is how a stationary wave is represented. Since we have not gone for the derivation part, that's not included for your syllabus, we just started with what are stationary waves. So that's the reason we haven't derived an expression for it. Okay? Because I couldn't change this because this was a cut copy paste. Everywhere there's error in the spelling. Right?
Ma'am.
Yes.
Ma'am, it's given centimeters, so we have to write everything like amplitude will be 3 centimeters.
Centimeters. But in case if you are finding the frequency, so what happens to omega? Omega will be 36 radians per second. No?
Yes, ma'am.
So frequency will be in hertz. But what about wavelength? What about wavelength, boys?
Is that in centimeters?
Now, how will you calculate wavelength here?
With the value of k.
Okay, k is equal to 2 pi by?
Lambda.
Lambda. Okay, now calculate the value of wave.
Ma'am, I got 2 pi by 0.018.
2 pi by?
Ma'am, 2000 centimeters.
Okay, 1 second. Boss.
Yes,
I'm sorry, ma'am. He's talking about wavelength?
Yeah, I think so.
Yeah.
Okay, yeah, continue.
because there are so many other functions. Okay, fine. What is the wavelength? You people have got this. This is correct. What is the wavelength?
Ma'am, 2 pi by
0.018, correct?
yes, ma'am.
Okay. First, centimeter should be converted to meters. Though x is given in centimeter, you have to convert it to meters. So when you're putting your amplitude, even it is 3 centimeter, you have to convert it to, then k is equal to 2 pi by lambda.
Ma'am, can you tell the value of wavelength again?
Wavelength is 3.49 meters.
All right, ma'am.
1 second. Your velocity v is equal to 20 meters per second.
Ma'am, class over, right?
What happened? Is time up?
Oh, yes, ma'am.
Okay. Sorry. So tomorrow's class, we'll finish this. We'll have to go for transverse wave in stretch string. Next, we have to go for numericals on